Hello, everybody, and welcome to lesson 7.4 and measuring angles. We're on page 458 in your textbook. Now, measuring angles and measuring segments are very similar. So lesson 7.3 is similar to this one. So make sure you watch them in sequence, measuring angles. So the symbol for angle is this sign. Notice this is less than, but this is angle. And the way you can tell is that this bottom here is horizontal and this is not. Okay, so these are not the same. All right. So let's underline our objective. We're going to find and compare the measures of angles. And in the middle of the page, we have the essential understanding. You can use number operations to find and compare the measure of angles. And when they say that, they really mean most of the time equations. So we're using equations and we have to solve them. And that's why we practiced a lot lately. Solving equations is super important in algebra and math, that you're good at that. So we're going to practice. So let's look at this. The word is angle, key concept. The definition of an angle: it is formed by two rays with the same endpoint. So if you look at this picture here, this is called a diagram in math. You got a ray here and another ray here, and this is the endpoint. Yeah, ray, ray, and in the middle is the angle. I usually make a arc to show the angle. Okay. The rays are the sides of the angle. There's ray and ray. These are the sides. The endpoint is the vertex. So A is the vertex. Yeah. So this is an important word. And how you can name an angle, there's three ways. You can name it by the vertex. So this would be angle A. Yeah, because A is the vertex. You can also name it by there's 3 points, yeah, one on each ray and the vertex. When you name it using the 3 points, the vertex has to be in the middle. Notice how the vertex letter is in the middle. But you can call it BAC or angle CAB, either way. It doesn't matter, okay? As long as the vertex is in the middle. Sometimes you have a number inside the angle and you can also name it by that number. So these are the ways to name angles. And yeah, again, this is reiterating the same story. Okay, so you need to know how to name an angle correctly. That's part of the lesson. Yeah, and you need to know what a vertex is. Yeah, and that's pretty much the important part on this box. When you name angles using okay, we just went over that. When you name angles using 3 points, the vertex must go in the middle. Super important. So these are the highlighted parts. You want to use a highlighter or underliner to train your eyes to go back to those things that you highlighted. Then we have to know what's interior and exterior. Interior are the points between the two rays. The exterior of an angle are all the other points on the outside. Okay, page 459. We're on the top. We're practicing naming angles. Yeah, part of your lesson is on that, how to name them correctly. And that information is on the previous page. We just went over it. Yes, it does go fast. However, you are able to pause your video and rewind if it's too fast for you, okay? So when I read a question, I need to make sense of it. So I'm looking what this means. This means angle KML. So he's using 3 letters. So now I go to the picture and I identify what angle are they talking about. KML. It's this angle right here. KML. This one. What are 2 other names? So I can call it angle 2. I can use the number. I cannot call it angle M because there are 2 angles attached to it, but I can reverse the order of the letters. Yeah, L, M, K. as long as M is in the middle. The vertex has to be in the middle. So those are two other ways. Would it be correct to name any of the angles angle M? No, because angle M is the vertex to two angles, actually three if you look at it. I should write three angles. The two smaller ones and the big one, the big angle also, yeah? So if you have more than one angle, you cannot use the vertex only. So it would not be clear which one you're talking about. The vertex to three angles. So it would not be clear which one you're talking about. So whenever you have more than one angle that you have going on in the picture, you do definitely want to use either the numbers or the 3 points that form the angle, okay? Okay, on the bottom of the page, one way to measure the size of an angle is in degrees. It's a little zero symbol that goes above the number. This means degrees. To indicate the measure of an angle, write a lowercase m in front of the angle symbol, like this. In the diagram, angle A is 62 degrees. You write this as, now here's how you read this. This is important. So I'm going to say measure angle. There's our angle symbol. A is 62 degrees. Yeah, that's what this symbol means. Yeah. So when we talk about degrees, the whole circle is how many degrees? It's 360 degrees, little angle degree symbol. So if I have a half a circle, it would be 180 degrees, right? Half of 360. So 180 degrees is a straight line. That's called a straight angle. So that's important to know. Now, if you draw a quarter, then it would be 90, 90, 90, 90 for right angles. So that's how the degrees come about. 360 degrees is a whole circle. Okay, up here, okay, it talks about it. A circle is the set of all points in a plane that are a given distance from a given point, which is your center. This is just a definition of a circle. Yeah, so you have the center and each distance to the outside of the circle is the same. By the way, that's called the radius. Okay, that's the definition of a circle. A circle has 360 degrees. So 1 degree is 1 divided by 360. So a degree is 1/360th part of a circle. This is not that important. It's just interesting for some people to know that. A protractor is this instrument. It measures the circle and it goes up to 180 degrees. You cannot measure the whole circle. So you can only measure angles that are less than 180 degrees. Okay, it's called a protractor. And it's the same as the ruler postulate in the previous lesson. It just means you can measure an angle with numbers. That's what this here means. And here, same thing, protractor, postulate. You can find the measure of an angle using this instrument. And if we were having more class time, maybe I'll find time we can use it to show you how to use it. Yeah. And again, remember that from the previous lesson with the absolute value, you can do it that way. I still believe for myself I like to do the biggest number minus the smaller number. It's okay, whatever you want to do. I'm going to write same as in lesson 7.3. Okay, please watch the lessons in sequence. Okay, it says it right here. Notice that this postulate are very similar or is very similar to the ruler postulate of the segment length. It's the very same thing. It means you can assign a number to an angle or segment. Okay, this is important. This is called angle classification. You can classify angles according to their measures. So these are the classifications you need to know. What is an acute angle? One that's between 0 and 90 degrees. Yeah, like that. What is a right angle? Exactly 90 degrees. Notice this symbol means 90 degrees. Okay, right here. Obtuse angle is measured between 90 and 180 degrees, so it's a pretty wide angle. And a straight angle, like we talked about, is a straight line which measures 180 degrees. Okay, so those are the 4 angle names you need to know. And one of the homework questions will ask to classify the angle, and you'll be like, what does that mean? Well, it comes back to this part. So I'm going to make it so you can find that information really easily. Okay, next. Measuring and classifying. Remember classifying? What kind are they? Just, oh, this is kind of interesting. How do you know whether to use the outer or inner scale of the protractor? You notice how the protractor has 2 scales. It's got the outer one and it has the inner one. So sometimes it's, which number do I use? Okay, what I always, there might be different answers for different people. I always say if it's an acute, I say acute, if it's an acute angle, less than 90, definitely you wouldn't use the big number, right? You'd use the small number. Acute, let's just call it acute versus obtuse. So I kind of am observant, how does my angle look? Is it bigger than 90 degrees? Then I'm not going to use the small number, I use the big number. So I have already a preconceived notion what my number should be. And there's probably a better explanation. On YouTube, you might find it and tell me what they said, because that's probably pretty lame right here. Okay, so I'm admitting to my ignorance on that part. Okay, so let's say we're going to find the measure and then classify if it's acute, right, obtuse, or straight. Okay, so let's look at number 3, angle DAF. Again, I have to figure out, there's so many things going on. DAF is a 90-degree angle. Do you see that 90 right here? There's no question. So that's that one. And that means it's right, because we're supposed to classify it, right? Classify. Then we have BAC. So I go to my picture, I start with BAC, and I like putting a little arc in it to show me which angle am I talking about. Notice this is an acute angle, so I'm going to write that down. It's definitely less than 90 degrees. It's pretty sharp, right? So now that I know it's acute, what numbers do I use? Is it 160 degrees or close to 20? Obviously, closer to that 20 mark, right? So now I have to estimate. Look, this is 20. And by the way, we're starting at 0. This is important. Look how this ray, this is a ray, starts at 0. So we don't have to subtract anything, because subtracting 0 will not change your answer. So I have 25 degrees. Look at that little degree mark. And then DAE is DAE is this one. It's also acute. DAE. And now I have to subtract, and I can use either numbers, because if I subtract 110 minus 90 or 90 minus 70, it doesn't matter. I'm taking the bigger number, so I'll use 90 and subtract the smaller number. And that's 20 degrees. Now in this case, if I do the upper row, then I would do 110, the bigger number, minus the smaller number. I still get 20 degrees. So in this case, it didn't matter which ones I use, but I made up another example to show you one where it does matter. So I say find angle FAC. FAC is this angle. Notice how I always show myself with these arcs. Where does the angle start? Where does it end? So that's important. Yeah. And so this is an obtuse angle, bigger than 90. And now I have to look. It starts at 0 and it goes, it's not 30. See how the upper number is 30? That doesn't make any sense since obtuse means bigger than 90. So definitely it's the lower one. And it's between 150 and 160. It's 155 degrees. So that's how that works. Okay. And here we're talking about, I'm not sure if we have discussed this symbol, I'm sure we have somewhere. Angles with the same measure are congruent angles. This is the word you need to know, congruent, okay? This means that if angle A and angle B are equal, then they must be congruent. The symbol for congruent is an equal with a tilde. Congruent means same measure. In geometry, we use congruent. In algebra, we use equal. Yeah. You can also say that if angle A is congruent to angle B, then they must also be equal. So we can kind of interchange those two symbols. Yeah. But still, the congruence means an extra word, measure. Yeah. Because in geometry, we measure a lot. Okay. So there is that symbol. You can mark angles with arcs, which is what I showed you here. You want to mark your angles with these round arcs, okay, to show they are congruent. If there's more than one set of congruent angles, each one is marked with a different number of arcs. So look at here. These angles are congruent because of these two arcs. These are the symbols to show they're congruent, okay? Okay, we're going on to next page. And we're looking at this photo and you see the arcs. And the arcs just tell you which angles are congruent. So one arc means these two angles are congruent. Two arcs means these two angles are congruent. Three arcs means these two angles are congruent. So that's what this all means. So if it says here, use the diagram, complete each statement. So I have measure angle EFD. So I go to my little picture EFD. This one here is 75. What is the measure of JAB? JAB, that's this angle. Notice they both have the same arc, so they're both equal. Yeah. And the next one says, if the measure of angle GHF. So I have to search for that angle, GHF, that's this angle with the two bows, is 130 degrees. What is JBC? JBC. C, that's this angle, has the same bows, so it's the same measure. So it's also 130 degrees. Okay, so that's the markings. The markings, how to mark your diagram or how to read it, the markings is important. Yeah, so make sure you understand that part. And here we come to that angle addition postulate, which is the same as the segment addition postulate. And or similar, it says here, so that's good. So remember when I say the sum of the parts is the whole, it's the same thing. And when I have the word is, I always mean equals, yeah? So angle addition postulate, oops, let me undo that. If point, here we have our stipulation. If point B is in the interior of angle AOC, B has to be in the inside. Yes, it is. Check, right? Yes. Interior, between these two, not on the outside, not out here, okay? Then you add up these two angle measures and you get the whole angle. The whole is the sum of the two parts. That's what this means. So I'm going to give you a little example. I want you to look if this angle is 30 degrees and this angle measures 70 degrees, what is the whole angle measure? The total, big one. What do you think? It's 100, right? 30 plus 70 is 100. But now, what is if I say the big angle, the whole angle, notice my bow goes from here to here, is 150 degrees. And let's say this angle here is 50 degrees. How much is left for this angle? How many degrees could this angle be? If you are thinking about it, you know it's 100 because 100 plus 50 is 150. Well, how did you get that? You can also say 150 minus 50 is 100 degrees. Now you subtract. So what this means is the whole minus the part. Oh, this is the word minus. Is equal to the other part. So that's how you can look at it. Yeah, the whole minus one part is equal to the other part. And now let's use it. Okay, notice we got x's going on. Whenever you see something like that, you know you have to write an equation. And so the plan here is, how can you write equation? But here's the trick. This is a straight line. A straight line has a 180-degree measure, right? So that's important. So we know that this angle plus this angle together will be the total angle, which the total angle is 180 degrees. So first of all, make sure you read the question. What are measure angle DEC and measure angle CEF? So the first step is to find x. So that's just to get us to this answer. A straight angle, 180 degrees. So our equation would look like this. The sum of the parts is equal to the whole. Excuse me. The sum of the parts is equal to the whole. There it is. And now we're going to combine like terms. I would suggest you stop the video and see if you can solve this equation yourself and then compare. 11 plus 2x is 13x. Negative 12 plus 10 is minus 2. Add 2. Divide by 13. $14 is the answer. But that's just to find the real answer is this. So I'm going to say measure angle DEC. So I'm looking for DEC. It's this one. DEC is this angle. That's 11x minus 12, and x is 14. 11 times 14 minus 12, use your calculator. $142 degrees. Notice it is obtuse. So I always watch if my answers make sense because it is an obtuse angle. So the measure is between 90 and 180. So that's one answer. And the other one, measure angle CEF. CEF, it's this angle, 2x plus 10. And that means 2 times 14 plus 10. 28 plus 10 is 38 degrees. And if you add these two, they should add up to 180, and they do. Yep, the sum is 180. And now we're done with that question, okay? And then I also wanted you to look at number 8. Usually I only give you one example, but I thought this lesson is short. Make it to you where you really are good at it. Notice these two angles, they're not a straight angle like that one, right? So that we need some more information. Here's the information. If measure angle ABD is 79 degrees, ABD, that's that whole angle, is 79. So the whole is 79. The sum of the parts, the sum of these two is the whole thing. So what's my equation look like? 5x plus 4, that's this angle, plus the other part is equal to the whole, which is 79. And now I'm not solving it. I just wanted you to see, maybe you guys can solve it and see if you can come up with the answer. Remember the question, read the question. Combine like terms and then get x, plug it back in to find the angle measure, okay? So your clues are usually the sum of the parts is equal to the whole. That's usually covers everything. And up here, that's again a straight angle. So the sum of the parts is the whole, which is 180. I'm not solving this one either. If you love to do it, your equation would be 6x plus 20 plus 2x plus 4 is equal to 180. But we're going on to the homework. And so lesson check is always your homework and a few more problems. You need to know how to name angles. So there it is. This one is really cool, number 11. If you can figure this out, an expression. The expression will use x in answer. So it's not a number, it's going to use x. And the clue to that question is right here. Nope, not here. It's right, yep, right here. angle addition postulate, the whole minus one part is equal to the other part. So this right here will help you with question 11. Okay. And then classify, meaning what kind of triangle is it? Right, obtuse, acute, or straight? And it is all this picture right here. Tells you. Okay. And then next page is number 14, an error. Okay, here on this one, I need to tell you that if you assume this is a right angle, you're wrong, because in geometry, we only go by markings. So unless you see, here's my clue, unless you see this little corner box, you do not know if this is a right angle or not. It could be close to a right angle, but maybe not. So don't ever go by what you see, what it looks like. It needs to be proven with markings. Okay, that's kind of the clue for that one. And then I have on the next page, this one is interesting, number 22. This is the same as the one where you have the whole minus a part is equal to the other part. So you have to pick which one is it. First, you have to understand the question, but match it up with a diagram, and then see which of these expressions would you use to find the missing angle. This one is really interesting. Number 23. Oh. Literature. I'm sure you've heard of the legend King Arthur and his knights sat around the round table to discuss matters of the kingdom. The photo shows a round table on display at Winchester Castle in England. From the center of the table, there it is, center of the table, each section has the same degree measure. So each of these sections has the same degree measure. Now you know the whole circle is 360, right? So if they all, so you need to see how many degrees does each of these segments have. And because they're all the same, you can find that. King Arthur occupied 2 of these sections. What is the total degree measure of his section? So he has 2. So you need to find 1 and then multiply it by 2. Okay, that's the clue. Is the whole circle is 360. And it's the same degree measure for each. And this one is interesting. If you know the clock, then you can figure out 24, 25, and 26, because the hands of a clock form an angle. What angle is it at 6 o'clock, at 7, and at 11? And also this one is super. This is so easy, but you've got to be able to read this and understand what's going on. So reading and math are intertwined. So don't tell me that, why do we have to read? Reading is always an important skill. You're not going to understand math unless you are able to comprehend reading as well. And so this is not a hard question if you can read it and understand the diagram. Okay, that's all it is. Thank you guys, and I'll see you. Make sure you have I will answer any of your questions next time we meet in class, okay?